Good day everyone, and welcome to my report on nanotechnology. In this report, we will explore the fascinating world of nanotechnology, which is one of the most exciting and rapidly developing fields of science and technology today. But first, allow me to introduce myself. My name is Joshua C. Ortoste, from BS Biology, major in Ecology 1B. So what is nanotechnology? Nanotechnology is the manipulation and engineering of materials and devices on a scale of less than 100 nanometers. This can include the creation of new materials with novel properties, as well as the development of tiny machines and devices that operate at the nanoscale. Nario Taniguchi of Tokyo Science University is credited with coining the term nanotechnology in 1974. The field of nanotechnology encompasses a wide range of scientific disciplines, including physics, chemistry, material science, and biology. It has the potential to revolutionize many areas of technology, including medicine, electronics, and energy production. Now, let's proceed to the classification of nanotechnology. Nanotechnology is classified in two ways. First is how they proceed, and the second is the medium in which they work. How they proceed is either descending top-down or ascending bottom-up. The medium in which they work is either dry or wet. First, how they proceed. Nanotechnology is approached in two ways in this category. First, the descending or top-down approach. It starts with a structure and tricks it. Objects are usually miniaturized in the 1 to 100 nanometers range. This is the most common method to date of working with mechanisms and structures, especially electronics. The opposite of descending is the ascending or bottom-up method. With this approach, one starts with a nanometric structures and builds up from there to create a larger structure. The second is the medium. The medium in which is worked depends on the material. Dry nanotechnology is used with materials that do not do well with moisture or humidity. This includes materials such as coal, silicone, and metals. Wet nanotechnology is used with more organic materials, especially those that will be found in a wet environment. These types of materials will be things such as enzymes, membranes, and cellular components. Now, let's proceed to the types of nanotechnology. There are several different types of nanotechnology, each with their own unique applications and characteristics. Some examples include number 1, nanomaterials, number 2, nanoelectronics, number 3, nano-optics, number 4, nanomedicine, number 5, nanoenergy, number 6, nanorobotics. Nanomaterials. Nanomaterials are materials that have been found, engineered, or manipulated at the nanoscales, leading to new properties or behavior compared to their bulk counterparts. Some examples of nanomaterials include carbon nanotubes, nanoparticles, and quantum dots. Nanoelectronics. Nanoelectronics involves the use of tiny transistors and other electronic components at the nanoscale to create faster and more efficient electronic devices. Examples include nanoscale transistors and memory devices. Nano-optics. Nano-optics involves the manipulation of light at a nanoscale, leading to the development of new optical devices and technologies. Examples include nano-antennas and nano-optical fibers. Nanomedicine. Nanomedicine is the application of nanotechnology to the medical field. It involves the use of tiny particles and devices at the nanoscale to diagnose and treat diseases. Examples include targeted drug delivery systems and diagnostic nanoparticles. Nanoenergy. Nanoenergy is the application of nanotechnology to the energy field. It involves the use of tiny devices and materials at the nanoscale to generate, store, and use energy more efficiently. Examples include nano-solar cells, nano-batteries, and nano-fuel cells. The last type of nanotechnology is the nanorobotics. Nanorobotics involves the development of tiny robots and machines that can operate at the nanoscale. Examples include molecular machines and nanorobots. Finally, let's proceed to the nanotechnology applications. Nanotechnology is helping to considerably improve, even revolutionize many technology and industry sectors, including medicine, material science, energy, environmental science, electronics and computing, personal care products, food safety, and among many others. In the medical application, nanotechnology has the potential to revolutionize medicine by enabling the development of new diagnostic tools and treatments. For example, nanoparticles can be used to deliver drugs directly to cancer cells, reducing the side effects associated with traditional chemotherapy. Nanoparticles can also be used to create contrast agents for imaging techniques such as MRI and CT scans, allowing for earlier and more accurate diagnosis of diseases. In addition, nanoscale biosensors can be used for early detection of diseases such as cancer and heart diseases. In the field of material science, nanotechnology can be used to create new and improved materials with enhanced properties. For example, nanocomposites can be made by combining nanoparticles with polymer matrix, resulting in materials that are stronger, lighter, and more durable than traditional materials. Nanoparticles can also be used to create coatings that are more wear-resistant and corrosion-resistant than traditional coatings. In the field of energy storage and production, nanotechnology can be used to improve energy storage and production. For example, solar cells made with nanoparticles are more efficient and less expensive than traditional solar cells. Nanoparticles can also be used to create batteries with higher energy densities, longer lifetimes, and faster charging times. In the field of environmental application, nanotechnology can be used to clean up environmental pollutants and protect the environment. For example, nanoparticles can be used to remove heavy metals and other pollutants from water and soil. Nanoparticles can also be used to create catalysts that convert pollutants into less harmful compounds. In the field of electronics and computing, nanotechnology can be used to create faster and more efficient electronic devices. For example, transistors made with nanoparticles are smaller, faster, and more energy efficient than traditional transistors. Nanoparticles can also be used to create memory devices with higher storage densities. In the field of cosmetics, nanoparticles are being used in cosmetics and personal care products to enhance their effectiveness. For example, nanoparticles can be used to create sunscreens that are more effective at blocking UV rays, and to create skincare products that penetrate more deeply into the skin. Last but not the least is the field of food science. Nanotechnology can be used to improve food safety, preservation, and taste. For example, nanoparticles can be used to create food packaging that keeps food fresh for longer periods of time. Nanoparticles can also be used to create food additives that enhance the flavor and nutritional value of the food. That's all. Thank you for watching.